All right, good evening, everybody. Welcome back to College Algebra. Today, we are going to talk about the difference quotient. Okay, this is a topic that plagues students for a long time. Hopefully, we can make the pathway a little bit easier for you to understand. Okay, so they want to say, given this function, right, x squared plus 7x, we want to find f of x plus 8, because all right, and figure this thing out. Okay, let me draw you a couple of pictures so you have an understanding of what we're looking at, and that might be a little bit helpful when you do a couple of problems. Okay, so I'm just going to draw my generic curve here. Okay, and what we're going to do now is we're going to have 2 points on this thing. Okay, we're going to pick a point A, and then we're going to look over, like, what's the y value? You could say y of A, right? But this is also f of, actually, we're going to, well, we'll call it A, it's fine. And we've got a value over here, B, okay? And we're going to look over here, and you could, again, you could call it y sub B. Okay, we can call this y sub B. We have y sub A equals, but this is really just f of B, okay? And then what we're doing here is we're taking the difference of the y's, we're taking this value, this is f of B minus f of A, and we're going to divide it by B minus A. This should look real familiar to you because we just did this, this average rate of change. Now we're calling it a different word, we're calling it difference quotient. Okay, so we're going to get that slope. Just 1 minus, right? So f of B minus f of A divided by B minus A. Okay, that's what we have. Okay, now I'm going to change what we call everything. Okay, in the next picture, it's the same idea. We're still doing this. Okay, I'm just going to change what the things are called so it looks vastly more complicated. Okay, so what we're going to do here is we're just going to draw another little graph here. We're just going to have our little, our little curve here. And then now, okay, we're gonna pick a point, okay, and they're gonna tell you, right, or they're just gonna leave it arbitrary. And we're just gonna call this one x. Okay, and then over here, what I'd like to do is I'd like to add something to x. Well, x plus a delta x, right? And we'll call that delta x, the change in x's. And we're going to call this point here, we're going to call this x plus delta x. Okay, off to the side here, right? The y value here, that's just equal to f of x, right? The function value at x. And then up here, okay, this is where it's going to get tricky. This is going to be this y value here. We could say, we'll say y1 and y2. This is f of x plus delta x. And then what we're going to do is we're going to go ahead and we're going to figure out the distance here, which is going to be f of x plus delta x minus f of x. Okay. And then we're going to divide by, right, x plus delta x. Actually, let's put that down here like I did last one. What we're going to do here is we're going to divide by x plus delta x minus x. This simplifies, doesn't it? Right, x plus delta x minus x, that's just going to be delta x. Okay, and this is exactly the same thing that we just did, right? This is x plus delta x minus f of x divided by delta x. Okay, that's this slope here. Okay, that's the slope here. It's still the same slope, except it isn't constant. So we call it difference quotient, right, or average rate of change. Those are both the same thing, right? Usually with average rate of change, there's specific. So with average rate of change, Usually there's a specific x1 and an x2 you're trying to find. Like, say I wanted to figure out how much a change in a stock went from, last week to this week. That would be an average rate of change because I could look those numbers up and then divide it by 7 days. Okay. For difference quotient, you're usually making it a little bit more general of an idea. Okay. And so you have to know like more what the curve looks like. But if I just wanted to figure out the average rate of change or the difference quotient here, I wouldn't necessarily put in dates. I would just kind of leave the formula as is and then type in the dates as I needed them. Okay, so we have a specific numbers in mind. This one is, we don't have specific numbers in mind yet. Okay, it's really the only difference here. Okay, so I tend to use them interchangeably. A lot of people do. Books will use them interchangeably. Average rate of change, difference quotient, they really mean the same thing. Okay. Notice that we have a horizontal change here, right? This is f of x plus h. We have a horizontal shift. Okay, that's all that's going on here, is that we moved it horizontally and we just evaluated the function at a different horizontal position than we did the first one. Okay. So somewhere along in the late 70s or 80s, 1980s, 1970s, 1980s, the book publishers somehow decided that delta x was too scary and too difficult of a concept for students, so they decided that they were going to call it h instead. Okay, it may have had something to do with typesetting, but since they still wrote chemistry books with delta x, I don't think that was it. But for some reason, they decided to go with delta x is equal to h. So if you want to write this thing old school, this is what you would do, is you write it this way. Ever since about the 1980s onward, they replace this h with a delta x. So you're going to see it as f of x plus h minus f of x, all divided by h. The h is really the change in the x. Okay. And really what we use this for is to measure small changes, because if you have been craftsman ever, or if you've ever put together anything from IKEA, you're going to realize that sometimes those holes aren't drilled exactly where the screws are supposed to go. That's a small error. So sometimes we use this to see, well, how, if my h is small, how much does this change in my function actually deal with? So if I miss my screw target by just a little bit, what does that do to the rest of the project? Sometimes you just force it, it doesn't matter. And that's the whole point, is you want that tolerance under where it's going to matter. And then anybody who's had a lovely experience saying these don't line up, and you've checked it's upside down and it doesn't work, like they drilled it in the wrong spot. That's when the h is too big, right? The change is too much. So it's above the error. Okay. So I just want you to think about, the fact that we're just doing an average rate of change. And when we go back to looking at our problem, right, all we're trying to do is figure out, like, what's the average rate of change, except I'm just not going to tell you which 2 points I want to do the average rate of change on. That's why they call it difference quotient and average rate of change. Okay. So when they have this here for you, and I don't want to give you problems where you have to memorize this formula. I don't think you should be memorizing this in college algebra. Okay, so I will try to pick problems where you have this available to you, because I just think it's, now next year, and I, even in pre-calc, I don't really expect people to memorize it. I usually write the problem, find the difference quotient, comma, this thing of this function. Okay, because I want you to be able to do it more than I want you to be able to memorize the thing. Now, when you get to Calc 1, because this is a long journey for us, when you get to Calc 1, you start expecting people to memorize this thing. Okay, so that's kind of the journey of you're introducing to it here. We do slightly harder ones in pre-calc, and then in Calc 1 we do, well, it jumps off and goes nuts after that. But yeah, but don't be afraid of it. It's really not as bad as it seems. Okay, so it is a bit tedious. Okay, so what did we have? We had x squared minus 7x or something. What am I doing? X squared plus 7x. Okay. So we're going to figure out the difference quotient for f of x equals x squared plus 7x. All right. Can we draw x squared plus 7x? Right? Do I know what that looks like? That's going to be x plus 7. So my zeros, right, are going to be x equals 0, x equals negative 7. Did you know the vertex is the average of the two intercepts? Okay, so 0 minus 7 divided by 2. My average is going to be 7/2, which is about negative 3.5, right? And I have to type this thing into the function in order to get the value for it, the y value for it. But here, I just want to know where to put it. Okay. So what we're going to have here is we're going to have 0, 1, 2, 3, 4, 5, 6, 7. Okay. So faces up, right? Parabola faces up. And at 1, 2, 3.5. So somewhere down here, there's going to be, let's go ahead and just do it. 3.5 squared plus 7 times negative 3.5, right? So we have 3.5 squared. I don't know what that is offhand. It's too big for me. In high school, we had to memorize all of our squares up to 25. I don't know them all anymore. I know a lot of them now, but I don't know them all. 7 times 3.5. I used to practice them while I swam. You're not doing anything else when you're swimming laps, right? So you might as well. We want 12.25 rather, minus 24.5. That gives you the last answer that you have. Okay, that second function, this sign with that A and S down there, I think every TI calculator has one of these. It just brings out the last thing you had as an answer. Okay, negative 12.25. Of course it is. So we'll say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 12.5 down here. All right, so here's our parabola. Okay, I'm going to say pretend that that's symmetric. Okay, and it looks pretty good. All right, now if I want the slope of the secant line between any 2 points, okay, so just think about what we're doing here is we're grabbing the slope of a secant line between 2 points. You have to know your original point, and you have to know how far you stepped. So if that's the 2 points I have, right? If that's my x, and here's my delta x, right? X would be something like -5, and my h, my delta x, would be +4. So it'll be -4, -5 plus 4 is going to be -1. This is going to be my average rate of change here. It's going to be my difference quotient. Do you see that? Any other color? No, it's too low. Do you see that if I picked any other 2 points, so this one has a negative slope, right? If I picked any other 2 points, I would get a different slope. So depending on my choice of x and h, my average rate of change, my difference quotient, is going to change. So if I give you a specific x and an h, and then I change it and I give you 2 different ones, then they're going to change. So why are you telling us this? Because here's the biggest mistake that students make. All right. So let me go ahead and I will use this color, okay, to signify this is bad and wrong. Okay, so this color, you will be most unhappy if you make this mistake. Okay, a lot of students, they don't know what to do with that h, so they just put it on the outside. They just say, well, f of x plus h, that's x squared plus 7x plus h, minus x squared plus 7x, because that's the next part of the formula, right? I didn't write it down on this page. And then all divided by h. And they say, oh, look, x minus x squared, that cancels. 7x minus 7x, that cancels. And I'm just left with h over h. And that equals 1. depending on my choice of x, is this ever going to change? No, it's always 1. Depending on my choice of h, is that ever going to change? No, it's always 1. So it doesn't matter what x and what h I pick. They're saying the slope is always 1. I will never ask you this question because the only function that you're going to get with a slope that is always 1, I'll say the family of functions, is y is equal to x plus b. This is the only one that has that 1 as a constant all the time. Okay, the slope is always 1. So if you're doing a problem, I ask you to do one of these, and you come up with an answer of 1, like if you plug in numbers, that's fine. That could be 1. But if you come up with like an answer that's just 1, the only function that was going to give you a 1 is this class of functions. And that is way too easy. I am never going to ask you x plus b, tell me what the slope is. Okay, that is I don't know. I'm a little bit off because my high school math was I was not good at math in high school and before. Okay, so for this would have been a 9th grade or a 10th grade question for me. I think most people, this was probably an 8th grade question, but if it was 9th grade, I mean, you know, you're right there with me, so that's okay. So yeah, but I'm never going to ask you this one. It's just way too easy. Yeah, identify the slope of this question, or this line. Okay, that's newbie stuff. Okay, how do you do this problem correctly? Right, so this is a good way. Right, so we're going to say f of x plus h minus f of x, all divided by h. Now, everywhere I see an x, I'm going to replace it with an x plus h. So we're going to say this is x plus h squared plus 7x plus h minus. Right? So this thing here, okay, I'm going to put it in a box. This is f of x plus h, that whole thing. And then minus, and we're going to say x squared plus 7x. Put it in that box. This box is f of x divided by h. Right? And that's how you set this problem up. Now we have to work through all of the stuff here and get a simplified form. Okay, that's our next step. So what is x plus h squared? Right, that is equal to x plus h. And honestly, for intermediate algebra, I know we're skipping intermediate algebra, but the two things you're supposed to learn in intermediate algebra, it's the 3 things, but the first thing is if you have 2 points, how to make a line between them. Okay, it's a really important skill for doing science later on. The next skill you're supposed to learn is when in doubt, FOIL. Okay, so next, the second major skill you learn in intermediate algebra is FOIL. Every time you're going to multiply. So this is a bad mistake. Don't do that. That's not good. We're going to go ahead and say this is x squared, right? Because first we have an xh, and we have another xh plus an h squared. So we have x squared plus 2 xh's plus h squared. Okay, so this thing here, this is x squared plus 2 xh's plus h squared. All right, minus. I'm going to go ahead and distribute. Oh, well, sorry, I'm not done yet. Actually, I'm going to wait to distribute until I get my next line, because I want to just do all my distributing at the same time. So did I have to do it this way? No, it keeps me from making a mistake. So the first thing I did, all I did was FOIL out that first part. So we're going to have x squared plus 2 xh plus h squared. And then we're going to have plus 7x plus 7h. So if you avoided the first mistake of putting the h on the outside, here's the next place you're going to make a mistake. This negative has to apply to both. It's going to be minus x squared minus 7x. All right, so make sure you're good at distributing, and this visits both. Okay. Some stuff cancels, doesn't it? Right? We have an x squared and an x squared. we have a 7x, and we have a negative 7x. Okay, the original function should always cancel out. Okay, that f of x, you should have nothing left there. All right. And then what do we have left? We have, this is 2xh plus h squared plus 7h, all divided by h. What I'm going to do next is I'm going to go a little bit slow. I'm going to make one more step than I really need to, because I want to make this real deliberate so you can see what's happening. So that h comes out. We have a 2x plus h, because if I multiply it through, I got h squared plus 7, all divided by h. And the reason I do it this way is because I don't want to cancel the first h and then forget about the rest of them and just move on with my life. I don't want to just cancel these two, and then these last two are just hanging out. Like, no, we got to pull an h out of each term, and then you can cancel. All right. Again, third mistake people always make. You cancel the first one, you say, great, I'm done. All right, and there's my answer. And you're going to say to yourself, that does not look like an answer. Okay, but it is. You are done with this problem when you've canceled this h. Okay, once you've canceled that bottom h, that means you're finished. Okay, that's what we're looking for. Notice that my answer has an x and an h in it. So if I hand you an x and I hand you a step, that's like, okay, well, what's my delta x and what's my starting position? You could figure out that formula. Just like we showed up in the picture up here, right? We had to give you an x and a delta x, an x and a delta x. And the slope changed depending on where you started and how big of a step you took. So it's important to look back at your answer here and look at it and say, does this make sense? Like, yeah, it does, because we have to have a start, we have a step, and then we get an answer. Okay. Most functions are going to have both x's and h's in your answer, because you need a start and you need a step. So if I started up here, down here, right, we're going to get way different answers than the other two that I wrote down here. Okay, so it's really important to know, like, where on the graph are you and how big of a step away from that original spot are you taking? Okay. So be really careful about that. I know, and I felt the same way when I was doing this. I hated this problem, but it's when you see it from the other side, it's something you're going to build on, and you're going to build on it. You're going to start it in college algebra. You're going to build on it for pre-calc. You're going to build on it for trig, and you're going to build on it for calculus. So you're going to use this a lot. All right, and they're going to get harder. All right, this is a pretty tame one. Okay, I'll take a look at the one previous to that. All right, now here we're given f of x is equal to 7x minus 8. What's 7x minus 8 look like? It starts down here at negative 8, and then we have up 7 and 1 over, okay? And it's just going to be that line, isn't it? If I pick any 2 points on this line, like this one and this one, what's the slope? 7. What about this point and this point? 7. This point and this point? 7. It's always 7, isn't it? So when I get done with this answer, right, when I do my difference quotient here, you're only going to get one number, because it didn't matter, right? It didn't matter where I started. It didn't matter how much I stepped. The answer is always 7. Okay, so let's see if we can go ahead and check that out and make sure it works. So here we have, right? What's our problem was 7x minus 8. So we're going to have 7x plus h minus 8. Right? That's my f of x value. Minus 7x minus 8, all divided by h. Okay, that's how we set that up. I think in this case, I can go ahead and just do distributing, and I'll just do it across the way. So we have 7x plus 7h minus h minus 7x. Minus a minus is a plus 8, all divided by h. Right? And you can see there's some stuff that cancels, right? The 7x and that 7x cancel. This 8 and that 8 cancel. And all we're left with is 7h over h. Right, what's my finishing condition? The finishing condition is, did I cancel the bottom h? Well, here we go. We canceled it. So now it's a 1. And my answer is equal to 7. Right? Just so you know, I mean, we do this one as kind of a way for you to see it and hopefully make the connection between slope of the secant line versus slope of a line and try to draw that connection in a geometric sense. I am unlikely to ever ask you a question this easy. Okay, this one is way too nice. I probably would never, because most people, if you know what you're doing, right? Is they find the difference quotient and then give you a function. Like, okay, great, it's 3/2. Like, you're done. There's no work. So all you have to, in this, when you have a linear equation, all you have to do is figure out the slope, and then you've had it. That's the end of it. Okay, so I'm unlikely to say this is a good question. We should pick that one for a test. Maybe, right? It's like a warm up, but I'm not thrilled about asking you this question. Now this one up here with the with the parabola, absolutely, that's a perfectly fair question at your level. Okay. You just got to do the pre-calc people. We got all sorts of weird stuff happening with them. I didn't know this is what we were doing for algebra to change anymore. Did one of these. And we should probably do another. Let's see if I can find another one. That was yeah, let's do this one. Okay. So this is g of f of 5. Okay, we have g of f of 5. All right. Now, the computational way of doing this is g of f of 5. Okay. Now, the way I usually do these is say, okay, what's g say? G is the square root of 2x. What does f say? X cubed minus 8x. Okay, so my rule for g, say 2 times a number and then take its square root. Okay, so we're going to take 2 times some number and then we're going to take the square root of the whole thing. What number would you like to multiply 2 by? This one. Okay, because f says take a number, cube it, and then minus 8 times that number. Okay, so the number I want to multiply by 2 happens to be this one. So that's going to look like 2 cubed minus 8x. We're going to put that in parentheses. Okay, so this is going to be 2 times x cubed minus 8x, which is going to be 2x cubed minus 16x. I'm not sure exactly how the book is going to want it, but I would not want to do anything more than this. Oh, they wanted a 5. They wanted a 5. Okay, so what we're going to do is we're going to plug in. We're going to say what happens when x equals 5. So we have 2 times 5 cubed minus 16 times 5. So we have 2 times, what is 5 cubed? 125 minus, that's going to be 80. And 2 times 125, what is that, 250? Minus 80. All right. And what is that going to be? It's going to be 200 minus another 30. Right. So it's going to be square root of 170. Sure, that's a delightful number. Well, before I type it in, no, wait just a moment. If you remember how we did this thing yesterday, right? What did we say? This was g of f of x. What's f of 5 equal to, right? This is, if we feed f of 5, right, we're going to get an output, and then we're going to feed this output into g and see what the answer is. So f of 5 is, right, what is f? F is x cubed minus 8x. So this is 5 cubed minus 8 times 5. So this is what, 125 minus 40? I think that's going to give me 85 here. All right. Now we're going to figure out, well, what's g of 85? Well, g of 85 is what? We have 2 times, that equals the square root of 2 times 85. It's 160 plus 10 is going to be 70. It doesn't, if you have a number, and all they want you to do is figure out the value for this thing, it doesn't really matter which way you do it. I think doing it this way is probably a lot easier for a number, so stick with that. But there's going to be a day where they're just going to say, like, what if f is, or what if x is a? Like, a? Well, yeah, that means you got to go through do this. Okay, so that's what you can do. Okay, and actually with symbols, it still kind of works. But yeah, it's a little bit harder. Okay, so that was the square root of 170. Are they going to let me do this, or are they going to? They're going to be difficult, aren't they? Good with a laptop. Oh, you should see me at school when they do the laptops, because they have to do the mice, but they don't always work. Oh, it's hilarious. By that, I mean incredibly frustrating on my part. But that's okay. All right. What about something like this? We have f of f. Like, can you even do that? Like, yeah, you can. You can compose a function with itself. That's fine. So our f of x is equal to x cubed plus 4x. I don't know why they tell you the rest of this stuff. Maybe there's like parts B, C, and D that I didn't get to or whatever. So what's f say to do? Take a number, cube it, and then add 4 times that number. What number would you like to cube? So what we're going to do is we're going to make a little box. We're going to say cube that one plus 4 times some other number. What number would you like to do that to? Well, that's going to be x cubed plus 4x. It's going to be x cubed plus 4x. Right. Actually, I'm jumping the gun because they only want to know for -2. All right. And I don't want to go through and cube this thing because that's going to be too much fun. All right. That's going to be a lot of fun to do that. So I'm going to not do this symbolically because I don't think they would have asked you to do one like that symbolically. But what we're going to do is we're going to evaluate f of -2. This is the input. We're going to get an output. Then we're going to take whatever this output is and we're going to feed it back into f again and get our real output. Okay, so that's what we're doing here. Okay, what is f of -2? That is -2 cubed plus 4 times -2. Okay, so we can, if you cube a number and it's negative, it still stays negative, right? Because that's -2 times -2 times -2 does -8 plus -8 is -16. Really? Kind of hoping against hope here. Oh, it's positive. Jerks. All right. So this -16, we got to plug this in again. So f of -16 cubed plus 4 times -16. All right, I'll do the easy part here. You guys can do the, I should say this way. I'll do the hard one. You guys can do the easy one. What is 16? 16 is 2 to the 4th raised to the 3 what is it, 2 to the 12th? 2 to the 10th is 1024. 2 to the 11th is 2048. And 2 to the 12th is going to be 4096. All right. Sorry, Gen X. This is what they thought the new math was going to be for us because we had to do computers. So you had to know all of your powers of twos. Okay, we're just adding these together, right? I mean, we're $4,096 in debt, and then we spent $64 more. We're just going to have a bigger debt. So what is that going to be? 16, and we're going to be 4160 negative. Okay, so negative 4160. Oops, I want negative. All right. Hey, how about that? I can do arithmetic. All right. So there we go. All right. By the way, if you're using a calculator for this, that's fine. It doesn't matter. All right. These are delightful. Okay. Fortunately, this one is really nice because we have a polynomial that we're going to feed into a polynomial. Okay. The only time you have to worry about domains is when you get square roots or fractions. Okay. Later on, there'll be some other ones that you have to watch out for. But right now, if they just give you two polynomials, there's no reason to work this out. Like the domain, infinite, right? Oh, they want to know this first. Oh, geez. All right, so what are we doing? We're doing P of n. Let's do the whole thing. P of n of x. Okay, P of n. And this is, the way we would evaluate it is like that. Okay, so what's P say to do? P says, take a number, square it, and subtract 6 times that number. So P, take a number, square it, and subtract 6 from that square. Okay, so what we're going to do is we're going to say, well, what number would you like to square? Well, n, right? What does n say to do? N says to say, take a number and add 8 to it. Okay, minus 6 times that number. What number would you like to square? Well, x plus 8, of course. And then subtracting by 6 times x plus 8. All right. So the way I do this is I just use these brackets to like think about it as a box. And then what am I putting in the box? Is the n. Okay, what P goes on the outside, and I just make boxes for it. And then whatever goes on the inside, that goes inside of the boxes. Yeah, that's I think that's helped me do this problem and not mess it up. But there are other ways to think about it. If you had a high school tutor, if you had a high school teacher, you had a tutor that you talked to and said, do it this way, and that's working for you, you go right ahead and do it that way. Okay, however you think about it and it's working, that's the right way for you. So we have x plus 8 squared minus 6x plus 8. And now we got to go through and do this. So that's going to be x squared plus 16x plus 64. Let's do that off to the side here. So x times x is x squared. We have an 8x. We have a second 8x. And we have a 64. So it's going to be x squared plus 16x's plus 64. Okay. And then minus, and don't forget this minus has to visit both of them. Okay, so minus 6x minus 48. Okay, and then we have to combine these. So this is going to be x squared, 16 minus 6, that's going to be 10x's plus, right? And 64 minus 48, if you $64, you can spend 48 of them. Where am I looking at here? We're going to get 5, and 14 minus 8 is 6, and then we have $16 left. No, positive. Yeah, 48 plus 16 will give me 64. Good. All right, so that's that's what we have is x squared plus 10x plus 16. X squared plus 10x 16. I'm going to tell me to do the rest of them first. Oh, no, it didn't. The domain, okay, here's the nice thing about this one. Hopefully we'll get a stronger one, harder one next time. We have no restrictions for the domain here. We have no restrictions for the domain here. It's fine. It's polynomial. It's a trick question. Oops. Infinity, positive infinity. All right. So let's see. I'm wondering if all the ones they give you are like this or not. Oh, this one. No. Okay, they're not all like that. Okay, so let's go ahead and have a look at this one. So we have m is equal to the square root x plus 5. See, now we're going to have some problems because we got a square root. It's got to be positive. And n, this one's linear, so this is x minus 1. Okay, and what do they want to know? They want to know m of n. So what's m say to do? Because that's the outside function. It says take a number, add 5 to it, and then hit its square root. All right. What number would you like to add 5 to before you take the square root? Why, x minus 1, of course. So let's go ahead and just write that out. X minus 1 plus 5. Anything magic going on? Like, do I have to treat this one special? No, this is just, we're $1 in debt and then we pay back 5 of them. So all we're going to have here is square root x plus 4. Okay, we're just going to add them together. Now, what's my domain here? X plus 4 has to be greater than or equal to 0. So if we subtract 4 from both sides, we're going to get x is greater than or equal to -4. Okay. Now, the function I put in at the beginning, right, has a domain of, is fine. No restrictions. This one, right, where we're going to feed this to, we're not going to have to worry about that because this is what we're feeding it to. But as long as we're greater than x and greater than -4, then we're going to be okay here. Oh. X, what was it? Plus 4. Remember also, right? What is the function square root x plus 4 look like? Okay. That is a square root function, right? And a 4 shift to the left. Okay, so that's what that looks like. Okay, and then its domain, in interval notation, of course, is, what do we have here? We have x has to be greater than or equal to -4. Nope. Yep. So I want -4 here, and I don't care how big it is. And then we'll be okay. All right. So let's see what we have left of this section. More of this. Okay, Q of P. It's going to be a fun one. Okay, word problem. Excuse me. These are good. Okay. Okay. Same problem. Yeah. Oh. We'll save this one for tomorrow because this is definitely a fun problem. Well, it's fun for me. You're not going to find it to be so fun. And I almost always ask this one on your exam, by the way. So we get to, when you do number 20 tomorrow, we'll do a couple of them. We'll do it again, maybe again. And then Monday, we'll do it again. because these, I remember as a student, I hated this, but it's a good skill to have. If you're going to go into any kind of programming, this is a good skill, is being able to read this thing. Okay, so I'll tell you what. Let me go ahead and pause for everybody and stop recording for everybody. So for the people watching on video, I wish you a good evening, and we do that.